Okay, so let's say I want you to solve the differential equation dy dx equals x over y. Okay, and this is considered a separable differential equation, which isn't really that important for you right now, but if you do take more math, you'd like to know what this actually is. And it's separable because you can get the y's on one side and the x's on the other side. So it's like this. You're effectively like multiplying both sides by y when you do this, and then both sides by dx. Although that's not really technically, which I mean, you're not really doing that, but that is what you see as a student.
Okay.
So on the left here, it becomes the integral of y dy equals the integral of x dx.
All right.
Okay, so the first part is to separate the variables, and then you have to integrate both sides. And so you could get, easy or hard integrals on either side. So that's so on the left here, it's like 1/2 y squared. And on the right, it's also 1/2 x squared, because you're in
You just did the antiderivative.
Exactly, yeah. And then you have a plus c.
So it's y. Could you write it as like y squared over 2? That's fine too.
Yes.
Okay.
Yes.
Squared over 2. Okay.
Okay, and then these are almost always initial value problems. So I'll tell you that the 0.2 comma 4 is on the curve. I think that works. And then you have to solve for c.
Okay, so you plug in the x and y.
Yes.
Okay, so
Yes.
it's 4 squared over 2 equals 2 squared over 2 plus c. So then that's 16, 8, 4, 2, c. C equals 6.
Yeah. So then you have to rewrite this line right here. Now, your instructor probably said something at this point, which I'm about to ask you, is sometimes they want you to solve for y.
Mm-hmm.
Sometimes you can't. Like here, when you solve for y, you have to first solve for y squared. You multiply everything by 2. So you get x squared plus 12.
Right. Okay.
But and this is not part of this course, but like this is actually a hyperbola, and like when you solve it for y, it's plus or minus the square root of x squared plus 12. It's actually 2 functions, so it's more common to see this as your final answer, not the actual solve for y final answer.
Wait, why is it more common to see that though? Because
Well, y isn't. It's artificial to think that you always solve for y, because this previous line is the correct answer. This is not a function down here, as you know it. So I'm sorry, it's not. It's more math you take, the more, sort of like, oh no, this is actually how it really is, gets revealed. But
like on slide 7, and like we ended with the y squared, but then like the final answer was the y equals plus minus root thing.
okay.
So,
Yeah, and so I like, if you've got time between now and the exam, I would ask the instructor. So a lot of the online homeworks that I've seen over the years, they do stop here, which I feel is more consistent
right.
with like what is correct. But I mean, this isn't wrong. It's just
Right. I see.
That's just another way of doing it. So believe it or not, one of the hardest things to do in these problems is to solve for the constants. So let's do a few more examples of these, if you're okay with that.
Yeah.
Some other types here that, I mean, I don't think you'll see anything like this, but I mean, might as well just show you in case you do. Dy over dx equals e to the x minus y.
Dy dx. Okay.
So again, this is separable, which means that if I'm telling you it is possible to separate the variables. Now on the right here, you want to do a rewrite. and it may not be obvious, but there's this property, if you have e to the x plus y, this equals e to the x times e to the y. And so that applies here because it's e to the x times e to the minus y.
Okay.
Okay, and then e to the minus y is really 1 over e to the y.
Oh,
So you can further rewrite it like this. And again, no calculus, no differential equations. You're just rewriting it.
so now you do the antiderivative.
Well, you really have to have this line here where you move the ey to the left and the dx to the right. This line, like an instructor wants to see right here.
Okay. So then it's e.
E to the y.
Yeah, so it's just
Yeah, it's just that it's
the
not.
same, right?
Yeah, it looks more complicated than that, but
And then is there a point then?
yeah. So let me give you an IVP here that this is your initial value problem. So it'd be like 0 natural log of 3.
Okay. So it's e to the natural log of 3 equals e to the 0 plus c. So then that becomes 3 equals 1 plus c. C equals 2. And then you plug it back into the.
Yeah, so you get e to the y equals e to the x plus 2. Now, if you were to solve this for y, this is where it gets a little bit like,
Yeah.
you have to remember, you take the natural log of both sides.
Okay, so it's ln e to the y ln e to the x.
This is your final answer here.
Okay, so you can't do anything further with the right side.
No, there are problems where you can, but this is not one of them.
Okay.
Okay, so here's a problem I found that I think it's not obvious what to do, but we'll look at it next. So this, again, it is separable, I'm telling you that, but on your exam, it may just say to solve, and your goal is to get y to the other side. Now, so far we have only multiplied or divided, and that's really your only options here. You will never add or subtract.
Mm-hmm.
So you're not going to subtract 2y. So it's not obvious here, but you would divide both sides by 2y minus 1. And then,
okay.
and so the dx comes over here. Now on the right, when you divide the right by 2y minus 1, it just becomes 1 dx.
Why does the dx go to the other side?
It has to, because you're only integrating, just like up here, like you're integrating with respect to x on the right, y on the left, back up here, integrating with respect to x. The dx always moves to the other side, or whatever the bottom one is, like sometimes the dt.
Okay.
But it has to.
So then it's dy over 2y minus 1?
That's right. Or maybe writing it this way will be more helpful when you integrate 1 over 2y minus 1 times dy.
Okay. dy equals 1 dx. And then
so on the left here, let's make u 2y minus 1. And then
oh, so you have to do, wait, why are we doing the u thing now?
because once you get it down to an integral, you have all the other things in play, like u-substitution, just your rules.
But the other ones we just did the antiderivative, right?
It's the same thing.
Oh.
So antiderivative, integral, they're all the same thing. They mean exactly the same thing. Like this is just another, so like in calculus, you're integrating. And there's all these different options. There's just rules. And integrating is antiderivatives. There's u-substitutions.
Okay, gotcha.
And there's a bunch of other forks here that you may or may not get to in this class. So your du is 2 dy.
Mm-hmm.
So when you, on the left here, you write this as 1 over u. And then dy is du over 2.
Okay,
So if you want, you can bring that 1/2 out, 1/2 integral 1 over u du.
what about the right side?
We're gonna, yeah, I mean, that's still there this whole time.
Okay.
At some point, you can integrate it or not. You can do it at any step. You don't have to do them at the same time. You just have to eventually count for it. So on the left here, this is the natural log of the absolute value of u.
How did you get that?
Just that's a known rule. The integral of 1 over x dx is always the natural log of the absolute value of x.
Okay,
Yeah, a lot to remember. There's that integral reference sheet to look
Yeah.
at. This is a common one. This isn't a weird one. It's a common one. It's related to the power rule, but the power rule doesn't work when it's -1, which is the case, which is when you get 1 over x, that's x to the -1 power.
gotcha. So
Okay.
then it's plus c or
Yeah, I always put the c on the right, but on the left here, we actually have to back substitute that 2x, 2y minus 1.
right, put it back in. Okay.
And then on the right here, it's x plus c.
Okay.
Okay, so I'm going to give you an initial value problem. I have to wait till this step to tell you so that we can so you can actually do it. Let's go 3. Let's go -2, comma 1.
Okay. So it's 1/2 ln 2 times 1 minus 1. 92 plus c, so then that's 2 minus 1 is 1.
Natural log of 1 is 1. I'm sorry, 0.
Oh, okay, so then that's 0 equals
Yeah.
2 plus c. So then it's 2 is c is 2.
Right. So rewrite this line: 1/2 natural log absolute value 2y minus 1 equals x plus 2. And you do have to solve for y here.
Okay, so
Sorry, I didn't put the 2 there.
ln 2y minus 1 x plus 2.
So you multiply both of these by 2. Then you e both sides. 2y minus 1 equals e to the 2x plus 4.
It's just 2. Wouldn't it, if it's an absolute value, come out as 2y plus 1?
No, the absolute value doesn't affect the operators. It affects the like net result of it. Like there's really a parentheses
Oh,
here.
gotcha. Okay.
Yeah.
Wait, so then you just add the 1, and then you divide it by 2, right?
Yeah, 1 or 1/2 each side.
Okay, right, like e to the 2x plus 4 plus 1 over 2.
Yes, that works.
Okay.
If you can get this far on your own, you're really doing well. You really understand everything. Okay, one more example, and then we should move on to something else.
Okay.
This example illustrates another thing that you might have to do. Again, the whole like emphasis here is you have to be able to separate the variables. And you can only divide or multiply. You never add or subtract. And here you actually have to factor first. So if you remember that E problem you're doing there, you had to do a rewrite. Here you have to factor. You always have to do something to make it kind of work. So this is 2x plus x squared times y when you factor out the y.
So factor out the y. Okay.
Yeah.
2x plus x squared. Okay.
Okay, so then you move the y to the left by dividing. So you get dy over y integral, and you move the dx right. So you get integral 2x plus x squared dx.
All right, dx.
So the antiderivative on the left here is the natural log of the absolute value of y equals, and then these are power rules.
Okay, x squared plus x cubed over 3.
All right, yeah, and let's go 1 comma e this time. Make it a little bit more difficult.
All right, so ln of e 1 squared plus 1 cubed over 3. Oops. Cubed. C. Ln, is it ln, like, isn't the e in what is it called, absolute value?
It is, but e is positive, so you can take those away.
Oh, so then ln e is 1.
Yes.
Okay. 1 plus 1 over 3 plus c. So then you move that one over. So 0 minus 1/3.
Yeah, so you go back to your first line there, natural log absolute value of y equals x squared plus 1/3 x cubed minus 1/3. And then you have to solve for y.
So you raise it, so e, like
Yes,
e to the
yes,
ln.
yes.
Okay.
You e both sides, and you get y equals e to the x squared plus 1/3 x cubed minus 1/3.
Y equals e. Yep. And then you can't do anything else.
That's right.
All right. I feel like the first part is the hardest, like deciding how you get.
That's right. Yeah. I mean, we could spend the whole lesson on this. I don't recommend that, but you have to be really comfortable moving things around.
Yeah.
Like we didn't do one with any trig functions, but like, let's say, let me just write, I know I said I wouldn't just, but I'll do it anyway. Let's say it was dy dx equals cosine x over secant y.
Mhm.
So this would become integral dy secant y. Actually, let me go secant tangent y over here. So secant y tangent y equals integral dx or cosine x dx. Like that's possible. The other one I was thinking of is where you have to remember, like, let's say it's cosine x secant y. Well, if you divide by secant y on both sides, you get dy over secant y equals integral cosine x dx. But 1 over secant y here on the left, 1 over secant y is really cosine y. So it becomes integral cosine y dy. So there's stuff like that is hard to do if you're not comfortable with all the stuff you learned in math, your entire life, basically.
Mhm.
Okay, so we can move on to some population growths, exponential growths.
Okay.
Okay, so you saw in class on slide 8 that the growth or decay model is represented by this equation, dy dt, so using t instead of x, equals ky, and k is the growth.
Mhm.
Okay, and it's continuous growth. which may or may not be realistic, but we'll assume that it is for something that we're doing. So let's say they tell you, did your instructor give you any example problems? Because I'm about to go down a path that may or may not be true. I mean, I see the one on 10 and 11, but did you have any homework problems, or do you remember, were they?
We did them on Math Excel.
Okay.
Let me see.
Like maybe they were insects, populations, money.
Yeah, I think we definitely did some with money that on the Math Excel that it was like 30 years like later. Like you have to find the initial and then the, let me look. 7.4. So it would have been the radioactive decay of an isotope can be modeled by blah blah blah. Find the half. No, that's half-life.
It's related to this. So I'll just come up with some problems here. So you're gonna, let's just say that we know that inflation is on average it's 4%. Okay, and we say that it's continuous. So that's a very important underlying assumption for all this. That it's continuous. So K in our problem is 0.04. Now you do not have to do it for K, like you don't have to substitute this number in, but a lot of students do.
Oh, here's one on the Math Excel, like how many bacteria will the colony contain at the end of 12 hours? So
right.
Okay.
And we're gonna do something like that, but in your example, in your notes, you did not put K, you did not put the value of K in right away, but you can. Like if you know the growth, you should put that value in right away. So this is just another separable differential equation. It's the integral, okay, of dy over y, and it's most common to leave the number or the K on the right, equals integral 0.04 dt.
All right.
So on the left here, it's the natural log of the absolute value of y equals 0.04 t plus c.
Okay.
Now let's just say, and this is the first time it's your initial value problem is that initially the price of a gallon of milk was $2.
Okay.
Okay. So you normally put it in this line right here.
Yeah.
But we, in general, like usually you actually solve this for y and then substitute this in.
Okay.
So you're gonna do e to both sides here. So y equals e to the 0.04 t plus c. Okay, but we can do a rewrite here. And the rewrite is e to the 0.04 t times e to the c.
What's the like difference in?
Well, we're going to make e to the c our new c.
All right.
And what that does is this becomes y equals c, because this e to the c is c, e to the 0.04 t.
So now you plug in your point.
Yes, now you plug in that point.
So 2c e to the 0.04 times 0.
Yes, 0. So c equals 2.
Oh, I see. And then
that's why it's preferred, because normally your initial condition comes at wherever you actually started. So that's 2e to the 0.04 t. And let's say that t equals 0 corresponds to the year, I don't know, 2010. And we want to know how much a gallon of milk will cost in 2022.
so you multiply by 12.
You put 12 in for t.
Okay. And then do you need a calculator for that? though?
Yes, yes. So this is a calculator part of the class,
Okay.
unless they just want you to simply solve the growth equation symbolically, or they give you nice numbers where it works out.
Okay.
So what I don't see is an example where you get, numbers. You said you did in your math Excel. So we can do some problems like that I've got here. Any questions on this?
No, I think fine for now.
Okay. So another way that they give you this problem, and this may be the way that it was shown in class. Actually, before I do that, sorry. So what is maybe not made clear is that this right here, dy dt equals kt, always produces y of t equals ce to the kt. So this whole time in math, when you've been said, hey, use PERT, which is really this, it comes from this on the left. This differential equation produces this on the right. And every time, but they want you to show the steps of doing this. Like that's a classic exam question where you go through the steps we just did here to make this work. Now, when you look at this one on the right here, there are two constants, C and K, which means you need 2 points on the curve to get it. Okay, so now that I've said all that, when I snip in this question, you'll understand what I mean by that. So they give you an insect population and they say that on the 3rd day, there are 130. That's point number 1.
Okay.
And after the 7th day, there were 380.
So those are your 2 points.
Right. So let's work this one from here, even though it's the same every time. Because you will be asked to do this on the exam. I can almost guarantee it. So it's a separable differential equation. So there's no y. Sorry, I'm sorry, I put the wrong variable in here. It's y, not t.
Okay.
Same thing here. Okay, now it's correct. Okay, so we have dy over y integral equals integral k dt.
Why is it not k over dt like the other side?
So when you multiply both sides by dt, think about like where it is on the left. It's in the bottom, right?
Oh, I see.
And it's dt over 1.
Gotcha. Okay.
Someday somebody's gonna watch this video and tell me that you can't do that, and they're right. but that's essentially what you're doing. So you on the left here, you know that this is the natural log of the absolute value of y. And on the right, this is kt plus c. And again, like if it were me, I would practice writing these steps, because you will be asked to do it on an exam. So now we're going to solve for y.
So e
both sides, y equals e to the kt plus c. And then here the step is you have to actually like get c in front. So there's just a rewrite here. It's e to the kt times e to the c. And then kind of off to the side here, you say, oh, but e to the c is really c.
Times e to the c. Okay.
And then you get y equals ce to the kt.
ce. Okay, and then you plug weight, but you have 2 points.
That's right. So this time you have to plug them both in. Now there are other ways to do this, but this I'm trying to emphasize, like when you have 2 unknowns, you need 2 points. So you get 130 equals ce to the 3 times k, or k times 3, but either order is okay. And then the second point, you have 380 equals CE to the 7K.
Right. Okay. So then you solve for C?
Yes, so you do that by dividing here. It's probably been a while since you've done this. You actually want to put the larger one on top. So
you're dividing the two equations?
yes. So on the left here, you get 380 over 130 equals C over C, e to the 7th K over e to the 3K. And then you use some properties.
I don't remember doing this.
Yeah, well, you can also use substitution. Okay, but the C's cancel, and then you get e to the 7K minus 3K. That's x to the n over x to the m equals x to the n minus m.
So it's e to the 4K.
Yes. So again, this is a calculator problem because you don't have nice numbers here. You have to undo the e with ln.
380, 130. So that's just 4K. Right?
Yeah.
And then you divide by 4?
Yes.
Okay. Divide by 4. Divide by 4. And then the K is, what were we looking for? Was that the initial?
So that's one of the constants. So I don't know what this is, but let's just say, you get a number from that. You would go back to either of these lines right here, and you solve for the other variable.
Wait, so you plug in. So you do, wait, can you go down? So
yeah, do you have this number here?
No, I didn't get it.
Yeah, let me get it here. So log 380 over 130. So that's 1.0726.
Then it's divided by 4.
Yes, divided by 4. Thank you. So it's gonna make it even smaller. So divided by 4. So it's 0.2682. Okay, so that's K. So then you can go back to any of these other lines. Like, let's just choose this top one. 380.
Does it matter which one?
Say that one more time.
It doesn't matter which one.
It doesn't matter which one.
Okay.
There's your K, and so you can solve for C.
And what does C represent? Like, what are we looking for right now?
C.
But like, what does it represent in the problem? Like, what are they asking you? They're just asking you to find C, or they're asking you to find like initial.
They want you to write the equation to represent the growth. Let's go back to the question.
I see. They're not asking you to find. Okay.
Well, that's kind of this right in here is that question, write the equation. And then, but what they're actually asking for is C right there. But they could be asking to use T they could be asking you to like put a T value in like what's going to happen in the future.
Okay.
It depends. Like there's a lot of forks here. Like you can first, you always find the equation though, I guess is what I should have said. Like you always want to solve for C and K. Like that's a.
So then with this one, you're just gonna do 7 times 0.2682.
Yes. And so 58 is what I get for C.
Okay. And so that's the original.
Yes.
Whatever.
Yes. So then it could ask you, What is the value of C? It could ask you for the rate. It could ask you for the out in the future.
Where are you plugging this C back in, like to show the equation?
This right here.
Okay.
Everything past this line though is not calculus, but it's like part of this part of the course where you have to find the two constants.
Right. Okay.
Okay, so now we can do another problem if you would. I think it might be good to do.
Yeah.
Let me see if this one is reasonable. Yeah, we'll do this. I guess you might see something like this. It's all right, zircon sample contains 400 atoms, 4,000 atoms, the radioactive element 235U. Given that 235U has a half-life of 700 million years, how long would it take to decay to 125 atoms? Okay, so there's the assumption here that you are using this model. And so you're starting from that.
Okay.
And we did this in the previous problem, but this always produces y equals ce to the kt. And whether you have to show this work or not is, that's you're gonna have to find that out.
Okay.
I think you will, but let's assume you solved the differential equation. You get this.
Yeah.
There's two constants here, and it comes from the given information. So initially, there are 4,000 atoms. So you have to be able to take a sentence like this, and you did this in pre-calculus. You just didn't have to do this differential equation part.
Mm-hmm.
Okay, that's one. But then it says it has a half-life of 700 million years. So after 700 million years, it's down to 2,000.
You're just dividing the 4,000 by 2?
Yes.
Okay.
Now, a couple of things here, like one of the goals here is to determine C and K. And we can do that now from this information. The second is to write the equation, like that could be another goal here with C and K. Another goal is to use the equation to determine Y or T. But you always do 1 and 2, almost always.
Okay.
So now there's a shortcut here. You saw this in your notes. K is equal to the natural log of 2 over something. Yeah, I'm sorry. T, wait, half-life. Oh, I see. Yeah, T is equal to the natural log of 2 over K. This is sort of a shortcut. I don't know if you want to use this or not, or we can just put these numbers back into the equation.
What if you would need type K if you're going to use that?
Yeah, but you're given T. So to use this, you're given T. T is 700 in this example. This is T Y. But let's just use the equations because that's more clear here. So use the first equation and you get 4,000
C E to the K 0.
Right. And that produces C equals 4,000.
Yeah.
So when you get C, you just immediately use it. Y equals 4,000 E to the KT. And then we use that second point, the 700 comma 2,000. 2,000 equals 4,000 E to the K times 700.
Oh, so you're plugging the other point back into that equation? Okay.
Yes.
But then that's
You divide both sides by 4,000.
4,000.
E to the 700k. You undo both sides with natural log.
4,000. 1/2 E to 700k. Okay. ln 700k. And then divide by 700. Okay.
All right, so this is a pretty small number, which it just you'll have to get that in your calc. It's minus 9.9021 times 10 to the minus 4. So it's pretty small. But the goal, let's go back to our goals here. Determine C and K. We found C and we found K. So now you can rewrite the equation. You can write y equals 4,000 E to the minus 9.9021 times 10 to the minus 4th.
Oh my gosh. Okay.
Okay, and yeah, that's bad, times T. Okay, and then we can go back to the actual question here. Let me grab the actual question one more time, because sometimes you get so far down into like this stuff that you don't know what it's asking for. But here it says, how long would it take to decay to 125 atoms? That's why. So I mentioned the third goal is they either give you a T to find Y, or they give you a Y to find T. And you could be asked to do either.
Right. Okay.
So here it's 125 equals 4,000 E 909021 times 10 to the minus 4T. And you have to solve for T here.
Oh my god. So you would divide by 4,000.
That's right.
And then
Take the ln of both sides.
right.
And if you do enough of these, you'll actually see they are always the same, but always work them out. As, you know, as best you can.
Okay. And then that'll give you some number. Okay.
Yeah. Ends up giving you 3,500 million years.
Okay. All right.
Yeah, so you got a handout, differential equations, growth and decay. Any issues on any questions on that?
I don't think so. I don't think we finished it. Maybe I can send that probably to you tomorrow to do.
Okay, let's do a couple of u-substitution problems to close out here.
Okay.
Because I don't think we have time to practice anything else. See if I can find a decent one here. Okay, so let's do the integral minus 15 x to the 4th minus 3x to the 5th minus 1 to the 5th dx. What is the u here?
The negative 3x to the 5th minus 1.
Yes. Okay, so du is minus 15x to the 4th dx. And when you solve for dx,
yep.
you get this.
Wait, so you're just dividing?
Yes, dividing both sides by
du over. Yeah. Okay.
Okay, so now you know, this is the most important part. You got to get it back to something. You got to substitute in for what you have, but you don't have everything.
U to the 5th.
And if you've done it right, the x's will always cancel.
Right
A couple of rare exceptions, but
so then it's the integral u to the 5th du.
Yes. Now, you know, you should say to yourself, wow, that's a lot easier. And it is. Like, that's the whole point of this method, is it takes something that's really complicated and puts it into something that you know how to do.
So now you plug back in the u, right?
Not after you integrate.
Oh, right. So u to the 6th over
Yes.
6.
And then you back substitute your u.
Okay, so then it's, what was the u? Oh, there it is. Negative 3 x to the 5th minus 1 to the 6th over 6 plus c.
Good. Okay, let's do one more at least. We should be able to get this in. Natural log of x to the 5th. What
Wait,
is
can
your-
can you write it like, is the way I said it fine? Negative.
Yes. Yes.
Okay.
Yes. Someday you will write it this way, believe it or not. It will happen.
I still can't see it that way. That's 5 plus ln x.
Yes.
And then your du is,
Derivative.
1 plus 1 over x.
0. Derivative of 5 is 0.
0 over 1 over 0 plus 1 over x dx.
So you don't even want to write the 0. You want to just
1 over x dx.
yes. So dx is x du this time when you solve for dx.
Okay. So then it's integral of u to the 5th over x dx du. So then your x's cancel. So then it's u to the 5th du. That's u to the 6th over 6 plus c. Then you plug back in your u.
Yes.
5 plus ln x to the 6th over 6 plus c.
Perfect. So we got a lesson tomorrow, is that
Yeah.
right? What are we going to work on tomorrow? New stuff or more of?
I sent you the review, so probably just going through that.
I would ask if Newton's law of cooling is going to be on your exam. It's more complicated than what we did today, and you may
Let me
just want to.
check the right now. It says it is going to be on here.
Okay, we should spend a little time
Yeah, we can
looking
do
at that. It's a very interesting thing, but it's also more complicated. So,
Okay.
All right. Well, thank you so much for scheduling. I'll see you tomorrow. Have a great day.
Bye.
Bye now.